Good morning, everyone. Good morning, panelists. My name is Manny Calero. I'm a consulting solutions architect at ZEDEDA. We're an edge management and orchestration platform to help our customers solve business and technology challenges at the edge. Today, we want to jump in and talk about understanding containers and workloads at the edge and different approaches. So let me start with a question. Do all edge workloads really look the same? And the answer is really no. Some workloads are large, heavy, distributed, cloud-native applications that may require Kubernetes, and Kubernetes is fantastic for those. But um, some edge workloads are smaller, maybe a connector, single analytics engine, IoT broker, or perhaps a lightweight multi-service application. For those, maybe Docker Compose makes a lot of sense, and that's the right tool. It's fast, familiar. Developers are used to using Docker Compose locally on their laptops, ideal for brownfield or resource constrained sites. So to the point, we support both, and you can choose. With our platform, you can run either Kubernetes where it makes sense, or Docker Compose where that's a better fit. And now let's talk about, if developers are already using Docker Compose, why is it important that we bring that to the edge? So one of the biggest challenges at the edge is diversity of workloads. So in most environments, you don't have one type of application. You typically have many. You've got legacy VMs running, that have been running for years, to maybe Windows machines. At the same time, your developers are delivering modern containerized apps, often defined with Docker Compose. And looking ahead, there's always new container frameworks that are being introduced and services that are being introduced. So what makes us unique is that we don't force you to choose one model. We support them both. And instead, we provide a platform where you can run all of those workloads side by side and on the same edge node. So the bottom line is, whatever workload you have today and whatever you add tomorrow, we will support it and we can orchestrate them. So here's the real strength of our platform, and it comes down to flexibility. Most edge environments are often clean slates. You've got legacy applications that are still running in VMs. You've not containerized apps, but some are defined in Docker Compose for those that are containerized. And you may also have other modern container frameworks that are emerging. So with us, it doesn't make you choose one model. And whether you have 10 nodes or 10,000 nodes, we'll provide the same zero-touch provisioning and policy-based orchestration to make sure everything's consistent and scalable. So repeatable architecture is really important to us. And to be able to bring scale to the edge is really important, which is kind of what Docker Compose lacks, and it's the scalability piece. And that's what we bring to the table in delivering a Docker Compose solution. So whatever workloads you have today and whatever you bring tomorrow, we can help you, and our platform can orchestrate them.
Hey, Manny, it sounded like you said that most edge deployments are clean slates. Is that what you said?
Thank you for pointing. No, they are not clean slates. That we typically have a lot of legacy apps running.
And devices.
Exactly.
Old, yeah, exactly. That you want to reuse if you can. Okay.
Yeah, and that's one of the cool things I think Mortborg mentioned was about EvoS, which is it can run on very lightweight, very small form factor type of hardware. So it's really powerful in that sense to support legacy, smaller applications. So let's talk about how this works from the user perspective. So typically it'll be either a developer or enterprise user. They're deploying containers, they're creating their apps, they're containerizing it, and then they're typically using Docker Compose. That's a very simple tool. It's very powerful, it's very quick, very streamlined. And then from that perspective, they'll create the application, they'll have their YAML file already defined. And then from our marketplace, what they can do is they can, from the global marketplace, import into their local marketplace what we call a Docker Compose runtime. And then they can deploy their apps on there. So the runtime is in our app. It's maintained by ZEDEDA, so it's very important, right? We patch it, we update it. The whole lifecycle management is care and fed by ZEDEDA. And then once it's in place, the user can simply take their Docker Compose YAML files, their existing configurations that they're using today, and deploy them in the runtime. So the result is the applications are instantiated and running on the edge node, fully orchestrated and supported by ZEDEDA. So from the customer's point of view, it's a straight and simple flow. User, marketplace, put your YAML files in an app and orchestrate it on the runtime. So the benefits that we see and how we make it scalable to our customers is speed, right? Fast onboarding in minutes, same YAML files that they're currently using. We're flexible because we can not only support VMs and Docker Compose runtime, but also Kubernetes when needed. And then the really important part that and the gap that we fill is the scalability piece, right? If there's one missing piece to Docker Compose is the fact that it doesn't scale very well. It works very well in local environments, maybe small, 5-10 sites. But as you start to scale in the distributed edge, it becomes really important to have a platform that can take that repeatable architecture across geographies and then maintain that single control plane, roll out updates, roll them back, keep visibility across a fleet. And then, of course, consistency, repeatable architecture. So taking the same YAML files that you may be, compiling on your laptop and take that to the ZEDEDA orchestration and then create those predictable outcomes across dev, test, production, and lower, the operational risk that makes adoption frictionless. So now I want to show you just a quick diagram. I'm going to run a demo after this slide here. And what I'm doing is from the ZEDEDA platform, I'll be orchestrating onto 2 edge nodes, the same application. So to show you kind of how we deploy across the fleet. So you can see it in action. And then I'm going to sprinkle Terraform in that as well. I love Terraform, and we're very proud of our Terraform provider. So I'm going to be doing some of the deployment through that. I'm going to show how I can deploy the infrastructure to the point where we deploy the runtime, and then I'll kind of stagger it a little bit, deploy the runtime, and then deploy the apps, and then show you what they look like in the marketplace. So here I'm going to start the demo, and this is what our UI looks like. So we log in here. The first thing I want to do is show our dashboard, and then go through the different sections to show that there's no elements created. There's no networks, there's no edge nodes, there's no marketplace apps. And then the first thing is show the global edge apps. So if you go into our global marketplace and you click ZEDEDA, you're going to see that we have 3 Docker Compose runtimes. They're different flavors. I'm going to go ahead and import the large flavor into our local marketplace. So now you'll see if I click on here, there it is. And then once I go inside, you can see some of the particular elements within that runtime. So 4 CPUs, 8 gigs of memory, storage size. And then what I typically like to do, especially for the demo, is I clone the app. I don't necessarily have to use that. I can clone it and make some changes. In this case, what I did is I cloned it, and I'm going to reduce the persistent storage size to 20 gigs. The original had a 200 gig, but it shows that we can kind of tweak those applications in terms of sizing. And then I'm going to keep all the defaults the same after that. So here I've got a cloned application. So now what I'm going to do is I'm going to pull up my Terraform code. Here I kind of show the diagram again of what I was going to deploy, but I'm going to go through the Terraform code and kind of walk through what it takes to build the infrastructure. So it starts with a project that's kind of the umbrella, and then everything falls under that. You have your images, you have your storage repositories, of course, your edge nodes for onboarding, and then, of course, the applications where you define them, the network instances, and all in a single Terraform file. And then I'm going to deploy it to the point where I'm going to have my projects, my data store. This is where I would store applications. The image, this is where the package would be. And then a couple of networks and the applications that you're going to see in the marketplace that I'm going to have deployed through here. And these are the YAML files. I don't know if you can see it on my screen, but I feed the YAML file to the Terraform, and then the end result is in the marketplace. You're going to see the application, and then you're going to see the YAML file. So here I did a plan and apply, and then I'm going to show you how I created a couple of edge nodes. I created network instances for those and for the runtimes. I created the edge apps. So I created 4 edge apps. I created, very common apps that we see like Grafana, Ignition, and Splunk. And then within those, the YAML files are configured. Here, I'm going to wait a little bit. It takes a couple of minutes for the.
Quick question while this is coming up here. Yeah. Let's say I'm using some orchestration software that's not Terraform based. Can this be consumed with a API, right? Can I drive the ZEDEDA dashboard in cloud from that API?
Yeah, absolutely. So ZEDEDA is 100% API driven. Even the web UI that you see there is driving an API on the back end. So we have our API is published. So you can leverage Terraform, you can leverage our REST API. And also we have our ZCLI. So it's a very flexible platform, many ways of configure it. I happen to love Terraform. So that's the way I kind of orchestrate all of my my environments. And then here you can see the edge nodes came up. So they're green light. That means they're onboarded. What a typical experience for a customer is this gets shipped to a customer. They plug it in, turns on, phone's home, it's registered. And then that becomes a registered endpoint where you can start deploying apps. You can deploy your runtimes from that marketplace. So here I'm just showing some details around the edge nodes, the adapters that are available, some detail on that. And then here, what I'm going to do is now that the edge nodes are up and running, I'm going to go ahead and deploy the runtimes. I can still do this from the marketplace just by launching it. I wanted to show the flexibility of our platform, so I'm doing it through Terraform. So I just do a plan and apply here. And then as we go back to the dashboard, you're going to see that now I've got a couple of runtimes that are coming up. There's one that's already downloading. And then within a couple of minutes, they're up and running. They're green light. That runtime is ready for you to execute those YAML files that I mentioned before, that I also created. So once they're online, you can deploy your apps here. Now, you can deploy straight from here. And you can see as I click on the application, you can see the YAML information and particulars for each app. And then you can deploy it straight from here. I'm going to go ahead and deploy it through Terraform just to show the automation piece of this. Right after I show you this last YAML file for Ignition. Ignition is a very popular app for our manufacturing, oil and gas customers, very common application, automotive plants. So here's where I start deploying the apps. So I'm going to deploy the application across the 2 edge nodes. So both Grafana, Splunk, and of course, Ignition as well. And through that single entry for each one, it's going to spray it across the different edge nodes. So I'll just do a simple plan and apply again. And of course, I can do this with a single swoop, but that would be kind of a boring demo. So I kind of staggered it a little bit. So now you can see that the apps are being deployed. Those are the YAML files that I showed you. And now you can see how we can scale this. I don't have to go to each edge node and run a Docker compose command to make the application come up and run. I can simply do it from a centralized location like I'm doing here. I chose to do it through Terraform. You can also do it through the marketplace. Here, I kind of went into CLI to give you an idea what it looks like on the edge node. And you can see that the container image is being pulled. And then they start to come online. Now they're all loading. And then eventually all these will turn green. And then you'll have a running application. So here we got a couple that already came up. And then in this next section, I kind of went through the UIs to kind of show the apps running. I wanted to then pull each runtime and show the IP address that's on there. So I have a 158 address and a 106 address. So that would be the target of what application you want to access. So what I'm going to do here is to show you the URL. I'm going to open up all these apps. I kind of sped up the video a little bit on this one to get there. And then you can see 158 was my first node, and I can access Grafana. The application is available there. And then I went in node number 2, 106, logged into Splunk. So basically, both apps are running on both edge nodes. And then, of course, Ignition here. I show how we can automate the deployment of Ignition. It already pre-configures with a username and password. And I can take it further and configure, MQTT endpoints. And that is my demo. That concludes what I'm showing in the demo here.
I have a question regarding sequencing. It seems like you have to install Docker Compose on the edge nodes before you can install all those apps using Docker Compose. Is there something intelligent on the node side that understands the sequencing of the dependencies, or is that something you have to put into your Terraform configuration or your script?
So our system is built to queue things. For example, I can create an edge node and deploy network instances. It knows that the edge node isn't up, so it queues that job. Once the edge node is up, then deploys the application. Same applies here. When I deploy I can, with a single code, I can run the entire thing, and it knows to wait for, it's kind of a staggered approach. It knows that it has to wait for the edge node to come up, then the runtime to come up, and then the application to be deployed. So it knows how to queue up jobs in sequence.
And the different compose options you were showing, like the small, medium, large, that determines the size of I guess it's a virtual machine on the edge node that gets provisioned for running the Docker Compose apps.
Correct. Yeah, that defines the sizing. So the small, medium, and large. So if you have a very small edge compute, you can deploy the smaller. Now, those are predefined. However, as you saw, I can clone it and I can edit and even make it smaller, kind of reduce the footprint of the storage, even add networks and kind of tweak it in a way. The remaining element that stays consistent is the actual software that we manage and care feed. So that would be the operating system is going to run the Docker.
What degree can I change the size of that VM without any downtime, or does it require, if I want to add a network interface or change the number of CPUs, does that require rebooting all the apps on that node?
So you can make those changes, and then the apps would kind of go into like a halted state, and then kind of come back online and redeploy.
What sort of SDLC capabilities can you support here? This is a powerful deployment and rollback tool, but I'm just wondering if there's anything inherent in the platform, or if it would be a partner or some third party using the API to enable that for developing and managing the life cycle of an edge app.
So that can be a customer directly doing it from themselves, their IT department, their developers, or we have partners that are in the ecosystem that are trained and are fully ready to support customers in our platform. So we have it covered end to end, and then we have a very talented customer support team that kind of takes over as they go into production. So they're full end-to-end support either through the ecosystem of partners or from our own CX team, which is always involved.
Hi, my name is Chris Clark. I'm a solutions architect for ZEDEDA. I'm based out of Kansas City, and today I'm going to be discussing ZEDEDA Edge Kubernetes Service and when you would want to use it. So that's really what I want to start with today is when do you want to use Kubernetes, right? It's very complex. There's a lot of moving parts that go along with it. And so really, if you look at your stack, is it a complex application that needs to be managed? Is it a distributed workload that needs to run across multiple nodes? Do you need high scalability? Then you're probably going to want to deploy on something like a Kubernetes, if not Kubernetes itself. And one thing I do like about Kubernetes is that it has a very active community and of developers around it. So it's very easy to support, and there's always new features that are coming out. Now, ZEDEDA has our own Kubernetes service built into the platform. I'm going to go through a demo of that here in a minute, but before I do that, I wanted to show you guys just very briefly the architecture. And the reason is, A, just to let you know all of the hard work that went into it, but B, that we made it very simple to use. So while this looks very complex, it's very point and click, create a cluster, deploy an application. However, if you don't want to use the ZEDEDA cloud to interact with that cluster, you can do it directly with your kubectl commands, or you can use kubectl via ZEDEDA cloud. And there's a lot of ways to interact with that, whether you're using ZEDEDA cloud itself or using the Kubernetes API directly. So let's jump over and take a look at how to create a cluster. So what you're looking at here is the ZEDEDA cloud, and there's a whole lot that we can do on the left-hand side, but we're going to focus in solely on the Kubernetes service. So when I hover over that, you'll see that we have a bunch of different options. We can create clusters from the clusters section. There's a Kubernetes marketplace section where you could import applications. You can see what applications have been deployed. You can take a look at cluster grouping, and you can even add your Git repositories. So it's really very an all-inclusive system. Now, the creation of the cluster is quite simple. We click that, you'll notice that we have a number of clusters already created here in the ZEDEDA cloud. I can add new up in the upper right-hand side. We'll just give it a name, test, go next, select one of our projects, and from here we select one or then 3 or more nodes to add into that cluster. So we'll just kind of grab 3 random nodes there. We'll tell the configuration, which network adapters to use for this particular cluster. Once we do that, we hit next, and then we can finally add it down below. Now, it will take a couple of minutes to deploy, so in the interest of time, we're going to just jump right back to the clusters here and utilize one that's already installed, this Edge AI cluster. So if we wanted to see additional details, we could actually click into this. But before we go that deep, I want to show you the actual application deployment. So here's the Kubernetes marketplace I was talking about a moment ago. From here, it's very similar to what you saw with Manny's presentation. So it's a very streamlined experience between different technologies. So if we wanted to come out down here, we could take a look at something simple like a guest book, right? We could select that, and you'll be presented with all of the options that can be changed. This is done with the Helm chart. We can see all the different versions that are available to us, and we can click install there. Now, if you don't want to use that marketplace and you prefer to use your own Helm charts, you can. That can be done by bringing in your own Git repositories here as a data source. And we can actually see all of the applications that are already installed. So we have this Hello World application. If I select that, it's going to bring up all the information, and we see that there's a service associated with that of a kind service down here. Then we have a service count associated with it, and then we have a deployment above that. So this is the basic functionality of deploying a Kubernetes cluster. It's, as you can see, it's very, very simple. It's not as big and complex as you're probably used to with Kubernetes clusters. And we can even take this one step further down into the weeds. We can go back to our cluster and click on it. And without ever leaving ZEDEDA Cloud, we can see all of the details about all of the pods, the services, the storage, the policies. So we wanted to take a look at some events that are occurring. We'll go ahead and click that. It gets presented here, right in the web UI. We can select those to get additional detail. Maybe we want to go over here to the workloads, take a look at what cron jobs are running. Maybe we have a pod that is thrashing that we want to investigate, or we want to delete one so it gets rebuilt. We could take a look at all of those from here as well. Here's the service discovery section. Like I said, you can take a look at the storage. So you have your persistent volumes, your storage classes. I mean, this is very, very all-inclusive. So from ZEDEDA Cloud, you can go from no Kubernetes cluster to your very own Kubernetes cluster in a matter of minutes, and then attach it to your GitHub repo, bring in your own Helm charts, deploy applications, and you can start development work, within 10 minutes.
Yeah, a question about, it sounds like you're getting ready to offer up Q&A there.
Yeah.
So quick question on the scale. Sometimes when we're thinking about edge clusters, right, we're not thinking very large scale, but I wanted to ask about that. Like if we're thinking of pod scale, can we go up to say half rack of nodes, full rack, multiple racks? What are kind of the upper bounds of what we think of that ZEDEDA can do in the scale of running a Kubernetes cluster?
That's a really good question. I don't have the numbers for that on hand, so that I'll have to answer that offline.
It looks like it can go pretty far, right? If we're just talking about the orchestration side, and like you said, we can bolt it into our current GitOps and go from there. So I'd have to imagine it's pretty high.
Yeah.
For bounds there, other than just how much do you want to manage, right?
Yeah, and really all it's doing is managing the cluster, right? Those VMs that are actually clustered together, they're doing all the communication back and forth with one another. So there's really not a whole lot of overhead. So I'd imagine the upper limit is quite large.
I think that highlights one of the things about scalability with edge solutions. It tends to be a very large number of sites, each with a relatively limited amount of resource. So you're not
right.
You wouldn't typically have multiple racks in each location, unless it was somewhere like an oil and gas exploration. That's the kind of use case where you might have more capacity in that in the crawler that's doing the geotech stuff.
Yeah. Is there an option to even bolt in, like from a CNI perspective? Like, can I roll my own CNI in the solution, or is there something else that is already baked in from a networking perspective?
The deployment itself, it's already baked in from what I understand, but I have not messed with any of the other CNIs, but I think it's baked in from the actual creation of the cluster. And then you were highlighting something about edge hardware that I really like about this solution is I think that Kubernetes really does a very good job at complementing edge hardware because it's super easy to swap in and out new nodes or add capacity and scalability with something like this. Have EvoS on there, plug it in, have it check in, add it to a node, and then you have additional capacity, right?
So this is a ZEDEDA cluster manager. How does this compare? I mean, containers is kind of where it's at right now, and Edge is like the most active development.
Mm-hmm.
But I imagine quite possibly the majority of your customers right now are still running VMs, whether ESX or KVM or Acorn. And I'm just wondering how this experience compares, if it's okay to ask that. And no one's going to start a religious war with me about it. I'm just wondering, like, from an enterprise standpoint, wherever they're at, they're often doing both,
right?
Whether they're moving or not moving from one to the other. So I'm just wondering how the experience compares. If there's multiple panes of glass now, and if that's inevitable.
Yeah. So I think that the experience with this Kubernetes piece is much better for developers because they, even though it's being managed by ZEDEDA, they still have the ability to utilize the tooling that they're used to, right? So you can have your admins managing the cluster and the ZEDEDA side and seeing what data sources they're allowing to bring Helm charts in from. But at the same time, the developers are able to use their kubectl or whatever they have integrated with their IDEs. So you have multiple streams kind of going at once, right? So the experience, I think, is very robust in that regard. When you bring over the VMs from somewhere else into ZEDEDA, you have to bring them in, and it's managed, and everything's done inside of here. So that's a little bit of the contrast between the two, which is why I like this quite a bit, how it allows you to use the tooling that you want to use.
Well, that's endemic to the platform when it comes to VMs. I think it's genuinely a feature of the VM, and that's why it's not really a religious war. It's just a question of what you're trying to accomplish.
Mm-hmm.
So I think that when we talk to customers, the VMs are a necessary evil for them today and will be for the next few years because they have invested a lot of IP in some of those applications that are running. on those VMs, and a number of them in very old versions of Windows. So they're looking for the ability to continue to use those. But I think obviously everything they're doing that's new and future looking, they're trying to containerize. So all their focus is on putting new apps, in some cases rewriting existing apps and putting them in a container or running them in Kubernetes. So it's a combination of they want to be able to deploy both types of runtimes for the next few years as they migrate from the VM to an all Kubernetes or an all containers type of architecture.
The Kubernetes version and the image, it looks like it's using K3S. I assume that's correct.
Correct.
Is that how close to the current version of Kubernetes do you have versions available in the marketplace? And could someone roll their own instance of Kubernetes and deploy it to the cluster nodes if they didn't want to use the ZEDEDA's version?
Yes, the answer is how close we are to the most current one. I think we're one or two versions behind. When it comes to rolling their own, yes, they could. And there's a number of different ways we can support deployment of Kubernetes at the edge. One obviously is one where we provide kind of a end-to-end management. The other is where we provide them with the ability to deploy the Kubernetes runtime themselves. And that is basically where they get to choose which version of Kubernetes they want to deploy. So that option exists, yes.